Hey guys, today we're going to start a kind of like short and simple unit, and it's going to be on matrices. So, matrices is just the plural form of the word matrix, and a matrix is a rectangular table of numbers, and it's written in rows and columns. And matrices are commonly used in math whenever you're like solving systems of linear equations or doing something like that. Um, so, whenever you're talking about matrices, an element is just like one individual term that's in a matrix. So, like if I chose this, then that's an element of the matrix. And elements are written as A, and then they have like two numbers after them. So, the first number is going to be the row that the element is on, and the second number is going to be the column that the element is in. So the one that I circled here, A23, that's because it's in the second row and the third column. And then the dimensions of a matrix is something else you'll need to be able to classify matrices by. And the dimensions are M by N. And so what that means is it's going to be the number of rows by the number of columns. So the rows are going to go first. So then here's just a quick example. So I have matrix A written here, and you're going to want to name the dimensions of the matrix. So for the dimensions, that's going to be the rows by the columns. So there's 2 rows by 3 columns. And so then the number that's in position 2, 1, so we said that rows come first, so that means it's in the second row and it's in the first column. So that is going to be 2. And then position 1, 2 is going to be in the first row and the second column. So that's going to be our 3 right there. So then just getting into some of the operations that you can do with matrices. One thing that you can do is you can multiply a matrix by a single number, and that number is going to be called a scalar. And so a scalar is basically just a number on the outside of the matrix, and whenever you're multiplying the matrix by that number, you can look at it as you're kind of just distributing that scalar to each of the elements in the matrix. So if you had a matrix, and I'm just going to do a short one, like 1 by 2 matrix. So if I had one that was 2, 3, and that was my whole matrix, and then I had a scalar on the outside of, say, 4, then if I wanted to multiply 4 by that matrix, then I would just kind of distribute that 4 to both of those terms. So it would end up being 8. Ooh, there shouldn't be a comma in there. I did that out of habit. It would end up being 8, 12. And then that would be your new matrix after multiplying by the scalar of 4. So then I just want you guys to pause and try this example. You're trying to find matrix 2A, so that means that you're multiplying matrix A by a scalar of 2. And then unpause when you're ready to see me go over it. So we're going to have 2 on the outside, and then matrix A is 1, 3, 5, 2, 7, 1. And so I'm just going to multiply 2 by each of the elements in that matrix. So 2A is going to equal 2 times 1 is going to be 2. 2 times 3 is going to be 6. 2 times 5 is 10. 2 times 2 is just 4. 2 times 7 is 14. And then 2 times 1 is 2 again. So that would be the resulting matrix that you would get. So something else that you can do with matrices is just add and subtract them. So what you're going to do whenever you're doing that is you just add the numbers or subtract the numbers that are in the same position. So like if I wanted to add element 2, 2 for both of them and find like the sum, then I'm going to look at element 2, 2 in my first matrix and element 2, 2 in my second matrix. And then in the resulting matrix, it's just going to be element 2, 2 from the first one plus element 2, 2 from the second one. So it's probably easier to look at it without like trying to name what elements it are, like 1, 2, 2, 2, whatever. Just think of it as like you're adding the two middle elements in that one, and think of position more so. And then another thing to note is to be able to add or subtract two matrices, they have to have the same dimensions. If they have different dimensions, you're not going to be able to add or subtract them. So like if I had a matrix that was like 0, 3, 4, 7, and I wanted to add it to a matrix that was 2, 1, then I'm not going to be able to do that because they don't have the same dimensions. There's like, I could add 0 and 2 and 4 and 1, but there's nothing to add the other elements to. So that is not possible. So then I'm just going to quickly find A plus B and then B minus A for these two matrices. So you can pause and do it on your own and then unpause whenever you're ready to see it worked out if you feel confident that you can do it. If you want to see me do it first, then that's fine too. So first I'm going to do A plus B. So A is 1, 3, 5, 2, 7, 1 plus B, which is 0, 5, -3, -1, 6, and 10. And so I just need to add these by adding each element. So the first one is like 1 plus 0, and I'm going to get 1. And then I have 3 plus 5, and I'm going to get 8. 5 plus -3, and I would get 2. 2 plus -1, and I'm going to get 1 again. 7 plus 6, I would get 13. And then 11 plus, or not 11, 1 plus 10, and I would get 11. And so that would be my resulting matrix if we did matrix A plus matrix B. So then I'm also going to do, and I'll kind of draw a line in between here so we can see the two separate ones. I'm going to do matrix B, which is 0, 5, -3, -1, 6, 10. And I want to subtract matrix A. So that's 1, 3, 5, 2, 7, 1. And so I'm just going to subtract each individual element here. So I would have like 0 minus 1 is going to give me -1. And then I would have 5 minus 3 is going to give me 2. -3 minus 5 is going to give me -8. -1 minus 2 is -3. 6 minus 7 is going to be -1. And then 10 minus 1 is going to be 9. And so this would be our resulting matrix if we did matrix B minus matrix A. So for addition and subtraction, just remember that you are basically just adding or subtracting the elements based on their positions in the matrix. So then I want to just do a couple of examples that kind of combine all of that. So the first one that I have on here is 3A. So that's 3 times 1, 3, 5, 2, 7, 1. And then plus B, which is 0, 5, -3, -1, 6, and 10. So the first thing I'm going to do is I'm going to multiply the scalar of 3 times matrix A. And so I get 3 times 1 is 3, 3 times 3 is 9, 3 times 5 is 15, 3 times 2 is 6, 3 times 7 is 21, and 3 times 1 is 3. And so that's 3A, and then we still need to add B to that. So I'm going to copy B down. And then I just need to add these two. So my resulting matrix for 3A plus B is going to be 3 plus 0, which is going to be 3. 9 plus 5 is 14. 15 plus -3 is going to be 12. 6 plus -1 is going to be 5. 21 plus 6 is 27. And then 3 plus 10 is 13. And so that's going to be my resulting matrix for this 3A plus B. So then I'm going to come over here and I'm going to do 2B minus 4A. So first I need 2B. So that's 2 times this matrix, 0, 5, -3, -1, 6, 10. And I want to subtract 4 times matrix A, which is 1, 3, 5, 2, 7, 1. So first I'm just going to multiply these scalars by the matrices. So 2b is going to be 2 times 0, which is still 0. 2 times 5 is 10. 2 times -3 is -6. 2 times -1 is -2. 2 times 6 is 12. And then 2 times 10 is 20. And then I want to subtract 4 times matrix A. So to do 4 times matrix A, we have 4 times 1 is 4. 4 times 3 is going to be 12. 4 times 5 is 20. And try to write it a little neater than I did here so that you can see that these are actually 2 separate elements. So that one was 12. And then 4 times 2 is 8. 4 times 7 is 28. And 4 times 1 is 4. And so then I just need to actually subtract these two matrices, and our resulting matrix, 2b minus 4a, should be 0 minus 4 is -4, 10 minus 12 is -2, -6 minus 20 is -26, -2 minus 8 is -10, -2 minus 28 is going to be -30, and then 20 minus 4 is going to be 16. And so then this would be my resulting matrix from doing 2b minus 4a. So for multiplying by scalars in addition and subtraction, it's not going to get much more difficult than that. Remember, for addition and subtraction, they have to be the same dimensions. And if they're not, then there just isn't going to be a resulting matrix from that. And then for multiplying by scalars, just remember to kind of just distribute that scalar to each of the terms in the matrix. And that is about all for this topic on matrices.